Alex, what's up, man? How are you?
I'm fine, thanks. It's just early morning here in Israel.
What time is it, bro?
9:30 for me. It's super early morning.
Yeah, we know the pain, man. Thanks for joining us, bro. So we have like about half an hour. You wanna tell us a little bit about what you're going to be presenting shortly in the conference?
Yeah, sure. So the idea of this talk is to basically to demonstrate people how to perform AI red teaming, and it's a new thing. Most probably it's one of the first topics on how practically you can do that. There were a lot of presentations like on particular examples of how people break different AI applications, but there were no like step-by-step guide on how you can perform those types of assessments. So I think that's basically AI security is something that we should take into account in the next 10 years because it's something that will be everywhere, basically.
Actually, you started Adversa specifically to target AI, right? And AI security issues, right?
Yeah, exactly. Like, yeah.
Can you tell us a little bit more about like Adversa and like what you guys have been working on?
So I was into different areas of cybersecurity, from network security to databases and up to applications. And I think like 4 or 5 years ago, we used to develop a platform to detect anomalous user behavior. And we decided to use AI. We decided to use a lot of different fancy machine learning technologies to detect unusual behavior and detect hackers. And at some point of time, I found a research paper about vulnerabilities in deep learning networks. So where you basically can change few pixels in such way that AI will recognize cat instead of dog and so on. And I read this paper, like like mathematic details, and I was like, wait, what? Like, is that so easy? And is that so, that it's not just, it's so easy, but the problem is that it's the architecture flaw. It's a fundamental flaw of all AI systems, or at least the deep learning algorithms, which are currently everywhere. And I realized that we won't be able to build a system based on AI to find hackers unless we solve the problem of protecting AI. And that's how actually Adversa started. So pretty much that's it.
So when you talk about like, AI and actually testing the systems, right, they're all black boxes, right? I mean, they're not exactly, you're not going to go to an automobile manufacturer and they're not going to give you the model file, right? They're just going to give you the end result or end product and say test that, right? So how do you even begin to start testing something like that? As in, how do you make it reproducible? How do you make sure that actually the inputs that you're giving into the AI system are being measured correctly? As in, which parts of the system are being fooled? If you talk about like a self-driving car, for example, right? Like the sign recognition, there's lane guidance, there's lots of different systems that are interconnected. How do you then pinpoint where the flaw lies, right? As in, which sensor is causing the problem?
Yeah, I think you're touching here the few areas. The one area is like a white box type of thing. Mm-hmm. The interesting thing about AI is that many of the vulnerabilities are transferable. So if you try to if you basically find a vulnerability in some open source algorithm, there is a big chance that that vulnerability can be transferred to the other algorithm. Of course, you need to do some kind of adjustments. It's kind of the same thing as we had in exploit development. So there are various, operating systems, and there are various commands you need to implement in the exploit to be able to work in a different environment. But in general, the vulnerability is transferable. So in order to be able to make this vulnerability more transferable, and I will tell more details about that in the presentation, that you need to test it on as much different AI systems as possible. And if you test your exploit in various systems, the more systems you have, the more chances that it will work on other black box scenario. And in order to do that, there are different tricks. So you need to take into account all types of environment specific issues. Like you need to take into account that in physical 3D environment, there can be, the transferability is one thing, yes, and the other thing is that it should work in different environments. And if we talk about the physical environment, we should take into account that this, for example, the road sign that we want to build to hack a self-driving system, it should work in different with different lights on different distance to object in different we should take into account the different color rendering specifics of particular video device. So there are many things that should be taken into account, and basically when you construct the exploit, you need to fuzz all types of things that can happen.
Well, I mean,
so
when you
kind
think
of like this.
When you think about the models, right, like as you said, most of the AI systems or self-driving car systems, they're kind of like using the same networks, basically. There's the same different networks that they've employed in different ways. So the transferability, as you're mentioning, as in if I discover an exploit that works in this particular model, most likely it's going to work against the rest. But from an AI researcher standpoint, right, like, where do you even begin to get it solved? As in, let's just say you find a problem with Tesla self-driving car, right? It's not going to be just a Tesla problem. It's probably going to affect Volvo. It'll probably affect, any other self-driving car manufacturers as well. So how would you suggest to AI researchers if they wanted to start, fuzzing for AI model vulnerabilities? How would you go about doing it?
Sure. So first of all, we have a framework we call the awareness assessment assurance. So first of all, in terms of awareness, it's basically important thing to build a threat model to understand what are the particular attacks can happen, because you basically cannot protect from everything. Mm-hmm. So it's a fundamental flaw, and it's usually a trade-off between security and accuracy. So in order to protect the system, you have to understand what are the threats. So first step is to if you know the threats, then you can construct you can perform some kind of assessment or pen testing, and basically find what kind of attacks can break your system. Then when you found the vulnerabilities, then you have the most complex problem how to fix that. So, and this is, yes, I will mention in details in the presentation, but the problem currently is that it's not like a SQL injection where you kind of know how to fix it now. It's a vulnerability that if you, let's say I can create some adversarial stop sign, and you will take this photo. As you know, as Elon Musk says that in Test AI Day just a week ago, there was one question like about the adversarial examples for self-driving cars. So he said that he haven't seen it in a while, but if he will see it, they will just train the system to prevent such attacks, because they will have the example, so they will put this example in a training set, and that's it. But it doesn't work like this. So if you put this on the training set, you will protect just from this example.
Yes.
And a little bit of similar examples, but not the entire list of examples. So in order to protect the system, currently we have three high-level ways of how to do that. One is adversarial. One is to do something with the training. So different types of adversarial training, distillation. So something when we train the system, augmentation, and etc. There are different approaches. Some of them will work good. Some of them will work not good. But in general, those approaches can cost you a lot, because you need to retrain the system, and it can cost you like at least the same amount of time and money as to train system without adversarial examples, or probably like 10 times more, because you need to train it with various types of adversarial examples. The problem here is that you still won't be able to catch all of them. So then we have a second, but you should do that. It's like a basic thing. It's like to wash your teeth. So just,
if nothing else, at least you do this, right?
Yeah, adversarial training is something that you should do. And in some ways, adversarial training can help you to make the system more accurate. So it's a good way of training the system, like to make it better. Like if you just don't care about security, just simple adversarial training can make your system better in terms of accuracy. Second thing is to do something with the model itself. There are different activation functions that have work better in adversarial circumstances. You can add some layers, so you can do something with the architecture of the model. The advantages here is that you can really do something good, but the disadvantage is that you can have less accuracy when you do such kind of changes. The third approach is to do some kind of input, something with input, like if you have images, you can do a JPEG compression, so you can do something to avoid those adversarial examples. This approach probably one of the best ones, but the disadvantage of this approach is that it's very specific to particular application. So you cannot use it like very broadly. So if you have some approach to, let's say, detect the particular adversarial examples for the road signs and do something with it in physical world with this camera input, it won't be transferable to facial recognition.
It's domain specific.
Yeah, so we have 3 options, and we have detection, like it's additional. In addition to all of this, so those 3 approaches is like about known unknowns, and the detection is about unknown unknowns.
At Adversa, are you guys actually looking into the possibility of using like a Q-learning function in order to generate adversarial examples? So rewarding the model for producing better adversarial examples that would then be able to fool a facial recognition or a sign detector or whatever, lane guidance. Have you guys looked at that?
It's an interesting idea. We haven't tried that. Use reinforcement learning to find
drive the adversarial. Yeah.
adversarial examples. I think we don't use the particular Q-learning, but in our exploit we randomly search for something and then test it in different areas.
So would you equate your technique to kind of like fuzzing, as in like it's fuzzing for AI, or would you use a different term for it?
No, I think so. The technique is basically is based on the adversarial octopus. We call it adversarial octopus because it has 8 legs. So there are at least 8 different techniques to make the exploit better. So some techniques help the exploit to be more transferable. Those are ensemble learning. For example, some techniques help exploit to be more imperceptible. So we use smoothing to make it less imperceptible. So that, for example, if you see here, it's also like kind of adversarial example, but you can see that it's something strange. So we use more smoothing for, and some techniques we use for more accuracy. So some of them, for example, we use fuzzing to fuzz the face detection frame, because one of the interesting things in hacking facial recognition system is that you basically should break 2 AI systems altogether, because you have a face detection and then you have face recognition. So it's 2 AI systems. The problem here is that sometimes if you make some exploit for facial recognition system, it can break the functionality of face detection system, and it won't detect your face. And sometimes the face detection algorithms are different and making different frames. So in order to bypass it, we use fuzzing to fuzz the different types of frames for frame detection.
That's cool, man.
You mentioned about detection just now briefly. where and what do you actually detect in terms of, maybe say, a data poisoning attack or something, right, on the model? How does that work?
Sorry, can you repeat?
Yeah, you mentioned something about detection as a method of protection just now, right? So how would the detection of an attack against an AI system work?
Okay. There are, in general, there are 2 types of, 2 big categories of detection for AI attacks. One area is like supervised learning based, and other is unsupervised learning based. So for one type, we just train. It's basically training AI to recognize adversarial and non-adversarial examples. So you basically have a lot of examples of attacks and a lot of examples of normal behavior, and you train the specific system to do that. But it's a different system. So you don't touch your AI. You're just building another AI to perform detection.
I got an AI because you like AI, so I made an AI to detect your AI.
Yeah.
So that leads back to a supply chain problem.
Yeah, exactly.
More AIs.
So bro, I see we've got like 9 minutes before your talk. Maybe one last question. So about the trustworthiness of AI, right? Like, as in, I think everybody is concerned about how safe are these systems. As in, like, can I really lift my hands off the wheel, right? Like in a self-driving car. What do you think it's going to take for general people to adopt letting AI just kind of like run their lives, you know what I mean? And making more important decisions for them. As in, like, self-driving car, I would say it would be a big one, right? Like, letting a machine be in charge of your life at speed. What do you think it's going to take for people to feel more safe, as in that the AI system is trustworthy? Because it's black box, right? Like, nobody knows what's gone into it. Nobody knows what kind of resilience testing has been done. Nobody knows what kind of adversarial examples has it been shown. You know, you don't want to be that guy that was in that particular car at that particular time that something happened, right?
Yeah. It's the year ago when it was possible to travel, I traveled a lot around the world. I was asking people exactly the same question, like, would you trust a self-driving car? Would you sit in the self-driving car? And I was asking people like everywhere, in Amazon jungle, in Albania, like completely everywhere. Most of the people were saying like, no, I won't trust that, like never. So when I came to Israel, the first time I sat in the taxi, the guy said, when we will have self-driving cars? I'm so tired of riding, you know? And I was like, wow, it's so different. You know, it's really different. So like in some places of the world, we already more than trust those systems. In some places, we don't. So, I don't know. It's like any type of new invention. We will need time. But since Corona happened, I see that the speed of adoption is like very high. It's like much higher than we expected. So, like, there are good things, like people saying here, if life giving you the lime, make a lemonade. So here we have the same with Corona. So there are a lot of disadvantages, but there are many advantages here as well.
Fair enough. Thanks so much for joining us, bro. We'll let you get ready for your talk in about 5 minutes, and then we'll be watching it in the track shortly. Thanks for joining us, man.
Thanks. Yeah, thanks for inviting me in. Have a nice day.
See you soon, brother. Ciao.